Alrighty, back to the build. Got some time to spend with the DeLorean. Today I'm going to install the DeLorean Aftermarket Relay Upgrade Kit. So they have two upgrade kits that they have available. They have an NOS, new old stock, new original stock, and they have an aftermarket upgrade kit. I went with the aftermarket rather than having 40-year-old relays that have been sitting in a bin. I just got some new stuff. So I'm going to go through the kit one component at a time and show you how to install them. So from what I've heard of and what I've learned from the factory, in this very back corner there's what they call a fan fail module, and they always fail. And I don't mean like they always fail like, you know, normal things always fail. I mean like they always fail. So they've decided that putting a jumper in place of the module is a better idea, because what happens is that when the fan fail module fails, your fans don't work and then your engine overheats. So can't have that. Doesn't fit extremely tight. That's going to melt. So that isn't going to work. I don't like it. I have to pull that out. So this kit modernizes the relays from these old school, new original stock to basically these Bosch relays that you see here. And these are Bosch as well. They're just, you know, 1970s Bosch. Better design, better contacts. Happy, happy. Perhaps we'll take one of those apart. You realize I never lose this game, right? I mean, there's no point in fighting. You can't beat me. Alrighty, so inside of these relays, this is what it looks like. So on pretty much all relays, you're going to have 85, 86, 30, and 87. 87A, what that does is connect like this one to this one rather than this one to this one. In my experience, 85, 86 is going to be control, 30 and 87 is going to be the load. So if you wanted to test this relay, you could power 85 and 86, and then if you hear a click and then you have good connection between 30 and 87, that means your relay is good. But I usually don't even do that. What I do is I will remove the cover like we did here. It's not that difficult. There's like these little plastic, you see like the little plastic ridges. You just get your pocket screwdriver, pop those guys off, take the relay apart. Almost all relays can be done this way. Not all, but almost all. And then what you're looking for is this right here. As those two wires are energized, it energizes this winding and creates an electromagnet, which then pulls this guy in, click, and that's what that click of the relay that you're hearing. Electromagnet pulls in this spring-loaded contact, and then it makes connection between this and this one instead of this and this one. So that just kind of proves the point of why this has that fifth point, is that it's providing connection to this one or this one, connection either here or here. Anyhow, where these failures will occur, either in the winding, which almost never happens, or it's going to be in the contact. So in this case, I can see inside of here. I don't know if you guys can, but inside this contact, you'll see this kind of old schmoo. And in this case, I'm just going to take this thing apart so you can see what I'm talking about. If you look here, rough and kind of charred up. It should be nice and smooth. So if you look down inside of this one, also. And then instead of being a smooth disc contacting a smooth disc, you get all these little, if you were to zoom in really far, it'd be little ridges and valleys and stuff. And then those ridges are just touching the ridges, and you may not be able to get the amount of amperage through that connection. So it'll connect, tink. You end up having voltage drop right there in that connection by that huge resistance from that terrible connection. That's what you're looking for. You'll see like some discoloration and that nasty fuzzy burnt metal nonsense in that contact. If you see that schmoo, toss it. So in the instruction manual, they actually recommend that you pull off this cover and leave it off. They're saying that it's more helpful to let this guy breathe and stay cool than it is to leave the cover on. There's a new fuse in here. All the rest, you can see all these old school fuses. That's one of the things I'm going to do, is replace them with newer, more modern fuses, just to be safe. Is it overkill? Yes. But these things are known to have electrical problems and for these fuse boxes to melt. And yeah, I'm not going to deal with that. So we're going to go ahead and preventatively, because I'm all about prevention, replace these. Got some aftermarket hoo-ha in here. Anyway, what I found, I was trying to do this fan fail jumper connection. These two go together in one, and then these two, they don't fit very well in there. And if you know anything about electrical connections, if you have a loose connection and it kind of just comes right back out, that looseness is going to cause high resistance, which is then going to cause high heat, and then you're going to melt that part down inside of there. I'm going to take that part of the box out, and I'm going to squish those connections tighter. So this guy has to be in there like so, so then we have a good solid connection. Kind of like a Honda starter solenoid connection. Have you ever seen one of those fail? Man, it smells like old people in here. Yeah. How would you ever do this with the seat in? It's crazy to me to think that the people that built these cars in Dunbury, Ireland during the Civil War or whatever it was of the late 70s had no experience in building these cars or building cars at all. If you haven't heard of monkey hooks, these things are the business. Check them out. Also, look like they might work pretty good for this. Haha. Okay. A little pinch. Just a little pinch. There we go. Let's see how well this drag now. Much more like it. So with this jumper lead, it's kind of like a Y. There'll be two in one, and there'll be one in each with their own fuse. So you're going to want to put the one that has two in the center most forward connector, and then each of the others on the left and right side. You're not using the other two terminals with this modification. Yes. There we go. All right. 1, 2, 3, 4, 6, 9, and 10 with the relays provided in the kit. These are gold-colored relays with not contain the main fuel lambda identified as number 11 in the drawing. AC panel illumination relay. Illuminate. De-illuminate. Interior lamp delay unit. Not a relay. The Tach fuel relay number 15 is often just left hanging from the wire harness and may be anywhere in the electrical compartment. I bet it's you. And I bet you've been replaced. Because you look exactly like this. Most def. And that means we get to open up the old one and see what's inside. Ooh, pretty. What have we... Man, that smells funny. More, please. There's a capacitor. Oh! I broke it. Well, good thing I have two. Goodbye. Read and understand items 5 and 6 thoroughly before beginning work. Well, who wants to see inside this? I do. Who wants to bet I'm going to hurt myself doing this? Oh, look at that. Quite. Oh. So, got the circuit breaker apart, the old one, and it's a bimetallic strip. I guess that makes sense, obviously. So the way that these work, you run current through this. If it gets hot enough, like in this case 40 amps, then, or over 40 amps, it'll spoing, open the two contacts, and until it cools down, it stays open, and then it click, and it'll close back down once it cools off, and you have connection again, like an automatic resetting fuse. You hear that? That's factory spec. That was it. Alrighty, so this is what's going on. It is directional. I was sitting here putting this thing together like a dork, and it's totally directional. So you need to make sure that the power feed, in this case, after looking up the wiring diagram and all that stuff, the brown wire needs to be on the battery side of the circuit breaker, and the black wire needs to be on the load side of the circuit breaker. On the other circuit breaker, though, we have two wires going to each lead, and they're both going into these like spade style connectors, and they're pulling a fair amount of amperage. So they came with this doohickey where they've got like this bolt on and they add the leads, but they come off an angle, and with these big monster things, they kind of just, they take up way too much space. It's not very good contact for so much amperage. 25 amps on this one, 40 amps on that one. So I cut these guys off and I put on an eyelet. So I'm going to end up removing, don't drop the nut, these things, and just put the eyelet on like so and bolt it down. Much better contact. I also have some heat shrink tubing, so obviously I'm not going to leave this thing exposed. That has like a lining of adhesive inside, so as you heat it up, the glue melts and kind of oozes and fills that whole cavity and makes it a really good, clean, professional connection. That's more like it, like that. So I need some fire. So the way that I usually do these is I'll heat it up in the middle. And you don't want to get into the orange flame, because then you'll get soot and then it'll make a kind of a mess. You want to be able to see what you're doing. I like the clear ones too. Really helps to get an idea of what you're doing. I'll do the center, and then I'll work my way kind of slowly, top and bottom, to the back and the front. Make sure you get a good high quality one. It's really soft and gushy right now, so just let it do its thing. Or a way that you can do this faster is to get some compressed air and blow around it. It gets it back down to temperature, cures it really, really quickly. That's what I do when I'm in the shop. So if you look on this one, you'll see on the black, on one of them will say bat and the other one will either say aux or load. These tend to say aux. So the one that I just pulled off says aux right there. So on this one, you guys can see that, but bat and aux right there. And what I found is that when you pull these guys out, there's a fair amount of, I believe, what's called fretting corrosion. And it just kind of happens over time. When you'll notice, if you ever worked on old cars, like from the 50s or whatever, old Mustangs, pickup trucks, their fuse box can be the problem. Like just the fuse and the connection that the fuse has with the little terminals will be the failure, and then you just kind of have to work the fuse in and out a bunch of times in order to get a connection again. So in this case, it does appear like something like that is going on, and I believe that that's probably why a lot of these things have issues with melting, because you end up getting this corrosion, high resistance at the fuse contact point where the terminal and the fuse leg meet. I'm just taking this fuse and kind of working it in and out. I'm not worried about the fuse, obviously. What I'm trying to do is get that same kind of corrosion off of the contacts inside the fuse box, and this obviously is just the best tool to do it. So I'm just going to work these guys in and out a bunch of times until I get a nice clean connection, and then put a new fuse in it. Also identified by having 4 terminals, the brown wire connected to the bat and the other 1 or 2, typically red wires, to the aux terminal. That isn't the way mine is. These things are a bit of a bastard. Okay, brown to bat, schwink, and red to aux, and then reinstallation. Difficulty. Aggravation. All right, so that's how you install the Delorean electrical upgrade kit. Thanks for watching. Hope you enjoyed it.